Hello everybody and welcome back to another virtual math lesson with Mr. Zimmett. I hope all of you guys are staying safe and healthy during your stay-at-home shelter in place. So, today we're going to be learning about circles. Obviously, you already know some information about circles. You know about the radius, you know about area, circumference. You've learned those equations before of how to find area, circumference. Today, we're going to be talking about how to find the equation of a circle itself. And we're going to be doing so by referring back to geometry principles that we've learned throughout the year. So, let's start with the definition of a circle. The circle is all points that are a certain radius away from the center. Okay? That part I think we all know. But now let's talk about what happens when you actually insert a number into that equation. So if I have here a radius of 5, how do I find the x value and the y value of this point over here? That's what we're going to be discussing for the first part of this lesson. And the way that we can do that is by using the Pythagorean Theorem. So, we've learned earlier that if we have a right triangle with side lengths A and B for the legs, and C for the longest side, the hypotenuse, that we have this expression, the Pythagorean theorem, that a squared plus b squared is equal to c squared. What we're going to do is apply that knowledge to this circle. So this circle has a radius of 5, that's the c value. The a is the x value, and the b is the y value. So when we put in a squared, that's really x squared in this triangle, plus b squared is the y squared, is equal to c squared, the 5 squared. So what this is showing us is that all of these points here, these x's and y's, are really points along a right triangle. We could draw another one over here. This would be equally true, that this x squared plus this y squared is equal to that r squared. This might take a moment to sink in, and I encourage you to wait a moment and pause the video and rewatch it if you need to, because this is an important point in this lesson. How we can get to this form of the equation, x squared plus y squared is equal to 5 squared, from the Pythagorean theorem, by breaking up all these points over here into right triangles. And if you go down a little bit further on the worksheet, you can see that that's what's happening over here. They break it down into this triangle, into this triangle, into this, well, not exactly a triangle, but this line. And all of these hold true. You can see the work down here, that x squared plus y squared is going to be equal to the radius squared. In this case, the radius is 5. So the x squared plus y squared is equal to 5 squared. Okay, in all cases, a point on the circle follows the rule that x squared plus y squared is equal to the radius squared. That's one of the key points of this lesson. So, it goes over an example over here. I encourage you to work through that example. That's just using algebra skills to solve for y. But right now for us, I want to consider the more general case. Instead of being at the center, what happens instead of being at the origin, what happens at the center of the circle is not at the origin, but is instead at any 2 points. And we're going to call those 2 points A and B. So now, instead earlier, we had, here's the origin, and we had that circle being a radius away from the origin. Now the center is at A, B. And again, we're trying to figure out what is this x value and what is the y value. And once we do that, we'll have the general standard form of the equation for a circle. Okay, and this part might be confusing at first. There's a lot of letters going on here. So pause for a moment to try to figure it out, and I will also go over the explanation as slowly and clearly as I can. Our goal is to figure out the x and y value here. And we know that the center of the circle is at this point, A, comma, B. Okay, x is further along to the right than A is. So let's try drawing a line that represents A. This is A over here. And a line that represents x. Here's x, here's A. So they're trying to figure out what is the distance, what is this distance? Well, this distance over here is equal to the total, my x minus my A. I know that in class this has confused some of you, so think of it as if I had my A is 2 and my x is 7. What is the distance between them? Well, that's just 7 minus 2, or 5. So that's how we can approach this problem over here. We can figure out that this distance is x minus A. That's this leg of the triangle is x minus A. This leg of the triangle, for the same reason, and I encourage you to work it out as well, is y minus b. Okay, and this is r. So now, again, from the Pythagorean theorem, I can get x minus a squared, this leg, plus y minus b squared, this leg, is equal to the radius squared. And now we have enough information. This is a standard form of the equation. We have enough information to work through one of the examples on our worksheet, which actually isn't nearly as hard as it looks. What we did right now is a lot of background and theory, which is really good for us to have that foundation. The worksheet itself is relatively simple. So again, I wrote down the standard form of the equation right here on top of my sheet, so I have it handy. X minus a squared plus y minus b squared is equal to r squared. And it wants me to figure out what is the center. What is if I have a center of 1, 3, and I have a radius of 8, let's write it out in this form. Okay, and all I have to do is the center, I plug in those values. So my x value of the center is 1, I plug that in for the A. The y value of the center is 3, so I plug that in for the B. And I get that that's equal to the radius, which is 8 squared. And that's all. I can now simplify that. X minus 1 squared plus y minus 3 squared is equal to 8 squared. 8 times 8 is 64. And that's all I have to do. You can go through the rest of the examples the same way. Over here, for instance, my center, I put in x minus negative 16, be careful with that, squared plus y minus 13 squared is equal to the square root of 7 squared. This looks a little bit harder, but it's the same general idea. all I'm doing is I put minus whatever the center values are. In this case, we have a double negative, so when we simplify, that becomes plus 16, the double negatives, plus y minus 13 squared is equal the square root of 7 squared. Whenever I have a square root and a square, they cancel each other out. Okay, so that just becomes 7. I can work through the rest of the worksheet the same exact way. So that is for you guys to do. Okay, so that's the first part of the lesson. Now we're going to try graphing. Okay? So this right here, this general form exercise is really awesome. It goes over a lot of algebra that's involved in going between the standard form and general form. And that includes review of completing the square, which is what we did earlier this semester. So if you want that review, I do encourage you to do that. But right now, that's not necessary for what we need to do. This is just good extra practice for you. So I left it in there. What I do want to talk about is two last things. One is a unit circle. I want to introduce the name. So the unit circle is something that's going to come up very often in math next year, and it's going to be used all the time in trigonometry. Remember sine, cosine, tangent, pre-calculus and calculus. It's used very often in math. I just want you to see the name here, and this is the derivation. It's a circle centered at 0, 0. You can see it's at the origin with a radius of 1. And you can see that they get the equation x squared plus y squared is equal to 1. Okay, so just so you have that in the back of your mind, that you're introduced to that idea, so when you next hear of the unit circle, it'll be like, oh yeah, I remember at least hearing about that. A circle with radius 1, centered at the origin. Okay, so the final thing we're going to talk about is how to plot a circle by hand. So the way that you do that is if you have an equation of a circle, you plot the center AB. So here my A is going to be that 4, and my B is going to be that 2. And then what I'm going to do is I have a center of a circle. I'm going to plot points up, down, left, and right around the circle in order to sketch that graph. And I'll show you what I mean right here in our worksheet. So I will once again at the top write down the equation x minus a squared plus y minus b squared is equal to r squared. This is the equation that we're going to be using for a circle. So how can I figure that out here? Well, my a in this case is going to be negative 3. I say negative because it's, remember we have that negative here. The a is always going to be the opposite of what I see here. So the opposite of 3 is negative 3. Now the opposite of negative 4 is positive 4. I have a negative in this equation, so I just have to take the opposite of whatever I see here. That's going to be the center. So center of negative 3, 4. Let's plot that 1, 2, 3, 1, 2, 3, 4. Here's negative 3, 4. And now my radius is the square root of whatever is on the right side. Because I have r squared, I would have r squared is equal to 1. So r would be equal to the square root of 1. So square root of 1, in this case the square root of 1 is just 1. What that means is my radius is 1. So I'm going to plot points 1 away in all the directions. 1 away in all the directions from my center. And then I connect the dots on the outside. And you can see here that I have a small circle. Notice it's a small circle because my radius, my r squared over here, is small. It's only 1. compared to my r squared of 16, which gives us a much bigger radius of 4. So I have a bigger circle. The r squared here dictates, it tells us how big the circle is. So 1 is going to be a smaller circle than the 16. These numbers over here, the plus 3, the minus 4s, they tell us where in the graph they're going to be. Okay, and then you can graph all of them. You can follow both of these examples to finish the worksheet. And that is the lesson for today. This is an introduction to equations of circles, the derivation of them, and graphing them. So thank you very much for your attentiveness. I applaud you guys for continuing to work so hard. Stay safe, stay healthy. Reach out to me if you have any questions. I'm available if you need me. Bye-bye.